Our modern world is full of metals, polymers, plastics, and other synthetic materials. We are surrounded by a vast number of metallic objects and components, and clearly metal is an important element in many things we use on a daily basis. We fly worldwide in airplanes built from metals and composite materials, and every day millions of people drive to work in cars, while we trust bikes to safely carry our children as they paddle their way around the street. And after serious injuries, we visit hospitals to regain mobility because we can craft the best prostheses and replacement components from metal and high-quality synthetic materials. So many different kinds of metals and synthetics fit for so many purposes. And every time we trust them to last and keep doing what they are meant to do. But for a material to keep doing what design is intended to do, it needs to be durable enough to keep airplanes in the air and keep car engines running for many miles. Even when tiny and nearly invisible, special materials need to be strong enough to even keep our bones together. Material integrity is crucial, and a vital characteristic of any material for engineering purposes is its hardness value. INNOVATEST provides and delivers testing solutions. During this movie, we will tell you how we do this. From the moment people started alloying steel, they thought of ways to measure its hardness. The first testing method was more or less based on scratching the surface of an alloyed piece. How easy it was to scratch the surface often defined the hardness. This test soon proved a very unreliable method, and the need grew for a traceable and repeatable parameter. As time passed, engineers started to define material hardness by penetration, and later on, methods evolved into the measure of the amount of resistance that different materials present to penetration by a specifically shaped object. From the late 19th century onwards, based on a scale developed by Friedrich Mohs, who first characterized minerals based on their physical properties, engineers like Swede Johann August Brinell and Stanley Rockwell and Hugh Rockwell set the stage for modern hardness testing. Both metallic and non-metallic materials need to be tested for hardness because manufacturers need to rely on it. Worldwide safety standards require materials to have a specific hardness or stiffness. Metal objects especially, key components in many items we use on a daily basis, are required not to break.